In this video, we're going to focus on popping, or all of the pipes that are located in the manufacturing line and the manufacturing facility. So I kind of regarded this as the Mario Kart or Super Mario Brothers back in the day in previous lab videos, because it's all about the plumbing, and the Super Mario Brothers were plumbers, right? So we go down the little rabbit hole of a pipe, and what world will it take us to Bowser Land? That's what this is all about. So the popping, I have to understand, where is it coming from and where does it need to go, because these are the highways, these are the roads that the material will take in order to go from one location to the next. So the popping, though, is just more than the actual pipes. It does include the fittings and the joints that carry that material, whatever material that is, that carries that material from one spot to the next. So they can be made of many different materials, just like the tanks, right? I have choices, I have options. But if we are working in a sterile condition, it's probably going to be something like stainless steel that's going to be picked and selected versus any of the other material that might be out there. So when we pick out popping, or when a company picks the popping out, they are going to make a few decisions based on what that material is going to encounter. So depending on what you're making, depending on what's getting manufactured, maybe some of that material is safely placed into some type of popping material that others cannot be. So we're going to look at fluid type. Maybe how thick, how thin, what is it made of. We're going to look at temperatures. So is it hot? Is it cold? What's going on? We're going to look at pressures. So is it something that's going to be pressurized? Because if so, then that will need a different material than something else. And then we're also going to look at flow rates. So is it flowing through quickly, or is it barely trickling through? Because different popping material will handle these situations in a different way. The material can also be rigid or flexible. And these two terms, I think, are going to go ahead, you know what those terms mean. But the flexible version basically means that it can bend, and the rigid means that it is stagnant, it is molded, it is shaped, it's not going to change its shape over the course of time. It is what it is. Both of these are okay, but again, it really depends on what we're doing and what we are using. You know, what is our particular type of situation, because that's going to change the material, and that's also going to change the types of material that we are needing, as far as is it rigid, or is it flexible, or is it something in between? Sanitary processes are also going to be included. Very often we do need sanitary conditions. So hygienic popping or high purity popping has to be used in those situations. And anything that food or beverage or biopharma, personal care industry, anything that's going to make it to a consumer like that, that's going to be, swallowed or eaten or put onto your skin, all of that type has to be hygienic in nature. So we do have to go through sterility. We got to go through sanitary procedures, and stainless steel is the most common option for that. Because all of the other types of materials will actually gather and promote and sometimes help spread the nasty things that are going to be lurking in that popping if I'm not very careful. Also, at the same time, under sanitary processing, the tubing that we are using, the popping that we're using, there cannot be sharp turns or bends that are happening in that type of situation. Now, if it's not sanitary, then maybe I can get by with this. You know, sharp turns and sharp bends are going to be okay. But for the most part, we are working under the sanitary processing popping. We're going to make sure that we are using hygienic popping. We're going to make sure that we can clean it. We're going to make sure that nothing is contaminated, nothing stays behind, nothing lingers. And sharp turns or bends, like going down the road and then that is a no-no. You cannot do that. So you got to slowly turn these fluids in the area that you want them to go into. They cannot stagnate. So you cannot allow them to stay in the piping or tubing for long periods of time. They should not be located in an area that they can pull up and just stay there and just stay there and just stay there and stay there until someone later on, years down the road, finds a little pool of mutated babies. I mean, you just can't do that. So stagnation is going to be a problem. You also want them to be airtight, so all of the fittings and all of the joints, of course, have to be able to fit together quite nicely, so that way it prevents any substance or foreign particle from the outside to make its way inside. So everything has to be airtight. Nothing can leak out or nothing can leak in. And then finally, downward slopes are always going to be very important. So stuff can't really travel up very well. That is a no-no. You really don't want those types of situations to happen. If you can actually allow things to flow naturally down and then around a curve, but not sharp turns or bends, then you're going to have a better situation on your hands as far as the piping goes in the biomanufacturing arena. Transfer panels are also another thing that we need to talk about. Transfer panels, I like to maybe think of this as like a little spider web. So very often when a spider makes a web, it starts off with a center or a core, and then it kind of spokes out in all directions, kind of like this, right? And then the spider will go through and just start weaving these together over and over and over and over and over. Okay, so transfer panels are like the middle of the spider web. That's how I imagine them. So what's happening is that maybe this is vat number 1 and vat number 2 and vat number 3 and vat number 4, and there's material, and in number 1 and number 2 I want to pump number 1 in, but I want to take it into spot number 3. So I need to connect vat number 1 to the line for vat number 3, so that way I can transfer it to that location. And then maybe after it gets done with spot 3, I'm going to take number 3 and then I'm going to transfer it to number 2. So these transfer panels allow me to have access to how these fluids are going to be running and where do they go. So this is the hub, right? Again, if I think of subways or some type of metro station, there's often some of the stops that connect you to multiple points, and those are the transfer stops, and those are the transfer panels for us with fluid flow. So transfer panels are connection points. So what happens here is that there is a U-shaped tube that you're seeing in the picture. It's right there. And this U-shaped tube is connecting right now this valve to that valve. So there is a chance that maybe, just maybe, I don't want those two lines connected any longer. So what I can do is I'll close these off and I'll make sure that no fluid is flowing, and then I will pop off this U-shaped tube or this U-shaped pipe. That is our transfer panel. We're going to pop that out, and then sometimes they call that the horn. So they're going to pop that off, and then they're going to connect maybe 2 other spots or 2 other locations or 1 other location to where it needed to go. So it gives me control of how and where it goes. That allows you to switch from one incoming line to where you're going to direct it after that. So that is the term transfer panel, and that is the purpose of those when you see them out there in real life. Okay. Next up, we need to talk about technician jobs in terms of piping. You know, what are you responsible for? What should you go in? What should you be looking for? Chances are all of the tubing and all of the piping is going to be there. It's already installed. It's ready to go. We just need to make sure it's going to be working the proper way. So the first thing that we would want to do as a technician is check for leaks, making sure that nothing's corroding, nothing's rusting, nothing's leaking, especially around the joints. The joints are going to be the problem areas most of the time. That's where stuff likes to hang out. That's where things like to get damaged or cracked or whatever the case might be. So joints are bad news, and I want to keep a close eye on those in order to stay away from those problems as much as possible. Next up, I want to store the hoses correctly. Now, these are hoses that are going to be flexible. I want to make sure there's no kinks in them. I want to make sure they're not just laying out in the middle of the floor. I want to make sure they also have covered ends. That's very important because they need to be caps on them. We don't want any contamination to make its way inside of the tubing lines. So keeping them capped is going to help me with that. And they're going to have to stay clean. So I want to make sure that when I do take them, when I do maintenance them, when I do clean them, I'm storing them the proper way as much as possible. Number 3, double check all the connections. And the connection is basically going to be where one pipe is going to be connected to another pipe. And maybe there's some type of clamp that's on that holds that together. That connection is going to be very important. I want to make sure that those are not leaking, those are not dripping, those are not damaged in any form or in any fashion. Next up, number 4, it says control them, please. Make sure you don't have a fire hose situation. So what this means is that if you're not very careful, you're going to take a hose off and then fluid is going to be rushing through it. And then before you know it, this stuff is going to be in high pressure and then it's going to slap you all over the front yard. I mean, you've seen those training videos of the firemen that are trying to manage and contain a crazy hose that's just pumping water out the end. It just slings them around like a little gnat, and you don't want that to happen to you at all. So that's what that means. Just control them. When you do, use them, take care of them, transfer them, clean them, whatever the case might be. Number 5, bleed the pressure from them, please, before you do any kind of maintenance on them. So just like a pressure cooker, you want to slowly release the pressure because tubing is also under the pressure, just like the bioreactors and just like the fermenters are. So we're going to have to lower the pressure down. That way, when I take these hoses off, it is not under pressure and I don't get an explosion in my face. Number 6, we're going to check the temperatures of them as well, please. So those temperatures are going to be very important, especially if they're super cold. I mean, it will stick to my skin, and if it's super hot, it will scald me and it will burn me and I'll be going to the hospital no matter which case or scenario that I'm in. So I want to check the temperatures. Please don't just grab a hold of them with your bare hands. They might not look hot. They might not look cold. But guess what? They could be, and your eyeballs are not going to be able to tell you that. So make sure you use common sense. Don't grab hot things. Don't grab cold things. And you know what? Stainless steel hot and stainless steel cold looks very similar if you're in a hurry and you're not paying attention. So that is the story with popping. It is all about the tubes that carry fluids from one moment to the next. That's what you're seeing in the picture here. Some of the popping is located here, not all of it, of course. And this is a utility panel. So there's going to be some fluids or maybe some gases, maybe some water. I mean, who knows? Maybe some buffers. Who knows what these are going to be? But popping is everywhere. And those do need to be inspected. Those do need to be checked off. They do need a second signature most of the time. And there's just going to be people that's just going to maintenance them and maintain them and making sure they're working the proper way like they should. I mean, you don't want a plumbing leak in your home. And you certainly don't want a plumbing leak in a biomanufacturing facility either. So with that said, another kind of chunk of information down. And if I go back to one of our starting slides that we used in the very beginning, I said, hey, well, we're going to talk about tanks. Check. We're going to talk about popping. Well, check. That's something else that's gotten taken care of now. And then we're going to talk about pumps. So pumps are going to be moving the fluid. So the popping is going to be the highway, and those are the roads in order for my liquid to go from one location to the next. So in order to do that, you need a car. So the pumps are going to be the car that's going to be able to move the fluid, from one location to the next. So we need to talk about what types of pumps that we have in order to create these motions for us, in order to transfer these gases or these liquids or these solids from one location to the other. So different types of pumps are going to be out there. We're going to talk about the differences. Some more terminology is going to go through, and a little bit of maintenance on those pumps as well. So in the next video, that's where we'll pick up. I hope you are learning lots and lots of stuff, because if you are, that means you're doing your job and I'm doing mine. And I hope that I am.